Today we're solving what are called compound inequalities. It's like two inequalities in the same problem. So you're going to have what are called and inequalities and or inequalities. So and inequalities have solutions that work in both inequalities, where the graphs overlap. So it's going to look like this. You're not usually going to see the word and, but it'll be like -6 is less than x is less than or equal to 3. So we're going to put -6 and +3 on a number line, right? And put them wherever you want. Now if we were just graphing the inequality -6 is less than x, that would be an open dot on -6. And since the letter's written second, it would shade the opposite way. So that would shade everything to the right of -6. If I was just graphing the inequality x is less than or equal to 3, that would be a closed dot on 3 and everything to the left of 3. X is less than or equal to 3. So the reason why on and problems you shade in the middle is because that would be the only spot where these two inequalities overlap each other. So you just squiggle in the middle there. Now, or problems are all solutions only work in one inequality. So it works in either the first inequality or the second inequality. The nice thing about or ones is you're pretty much always going to see the word or. With and, you don't. It's like mushed in as one inequality, and the arrows are both facing the same direction. Or, you're going to see the word or. So if we were to graph x is less than or equal to -2, that would be a solid dot on -2, and it would be shaded to the left. Or x is greater than 5. That would be an open dot on 5, and everything shaded to the right. They have nothing in common. That works for both of them. There's no number that's less than or equal to -2 that's also greater than 5. It's impossible. So they're shaded in opposite directions. The way I remember that is or starts with an O. You shade towards the outside. And you shade in the middle. I have nothing for that one. I can write and graph a compound inequality. Ooh, look at these helpful hints. And problems, the arrows go in the same direction. So you have the small number is less than or equal to x is less than or equal to the larger number. Or ones, the arrows go in the opposite directions. So you'll have x is less than or equal to the small number, or x is greater than or equal to the larger number. You'll see. All real numbers greater than or equal to -2 and less than 3. It's an and problem. So we're going to write the smaller number first, the -2. We're going to put our x in the middle, our large number here. And then we just have to make sure that our inequalities are facing the correct way. So greater than or equal to -2. Now, we're writing less than or equal to, but really, -2 is less than or equal to x is the same as x is greater than or equal to -2. And less than 3. So the only reason we kind of flipped the sign on the first one is because we're writing the variable after the number. So we're going to make sure -2 and +3 are on there. The -2, the dot, it's got or equal to, so it's going to get a closed dot. The 3 is just less than, so it's going to get an open dot. This is an and problem, so we shade in the middle. Again, like the explanation for that is if we just graphed this inequality, it would shade everything to the right of it. If we just graphed this inequality, it would be everything to the left of that. We're shading where they overlap each other on this one. If you get a grade of 69 to 100 in Algebra 1, you go to geometry. So, all right. It's got to be between 69 and 100. Could it be exactly 69 and could it be exactly 100? Sure. But it's going to be in the middle of them. So we're going to say 69 is less than or equal to x is less than or equal to 100. Put them on the number line. They're both going to get full dots because it has the or equal to. And the numbers in between 69 and 100 work for both inequalities. Again, you don't see the word and there. It's written just like that as one single inequality. So let's write some compound inequalities from graphs. We're going to do the left two together, and then I want you to try out the right two. Now, number 3, look how it's shaded. Is that an and or problem? It's and because it's shaded in the middle. The two numbers that are important are the 5 and 8. It's an and problem, so we'll put the x in the middle. If you look, the 5 has a filled in dot, a closed dot, so it's going to have the or equal to. The 8 has an open dot, so it's just going to be less than like that. That's not too bad, right? If you look at example 4, it's heading in opposite directions. So this is an or problem. We're not putting it as one single inequality. We're going to write two separate inequalities. So this one over here for the -7, it's got an open dot and it's shaded to the left. So we're going to say x is less than -7. You could say -7 is greater than x. I don't know why you would, but technically that's the same thing. Or if you look at -2, it's got a filled in dot and it's shaded to the right, so that would be greater than or equal to. So why don't you guys try out 3 and 4 here. Do your best. If you look at number 3, it's shaded in the middle. It's an and problem, so we have 2 is less than or equal to x is less than or equal to 5, because they both have filled in dots. Try number 4 is shaded towards the outside, so I know that's an or problem. So for the -1, we'll say x is less than or equal to -1, or x is open dot greater than 8. Hopefully you got those right. Oops, okay. So, example 5. Do you see the word or? No. So this is an and inequality. You have the x in the middle, you have the arrows heading in the same direction. So if we were to graph it, which it doesn't ask us to, but we'll graph it anyway, we're going to shade in the middle. Now if we just had the equation or inequality 2x plus 3 is less than 7, we would subtract 3. The only difference now is we have to do it to all the parts. -3, -3, -3. -5 minus 3 is -8. Is less than or equal to. Those cancel, so we just have 2x in the middle. 7 minus 3 is 4. Now, if we were just solving 2x is less than 4, we would divide by 2. We're just going to do it to all the parts. Remember, if you divide or multiply by negative, you have to flip the inequalities, but we're good here. So we'll have -4 less than or equal to x is less than 2. This is an and problem, so if I was to graph it, I know it's going to shade in the middle. You always put your smaller number on the left. So -4 has the or equal to, so that's going to get a full dot. 2 is just less than, so it's going to get an open dot. And this is an and problem, so you shade in the middle. So I'd like you to pause, try out number 5, and see if you get the same thing that I get up here. Go ahead and try that out. Add 1 to all the sides. Divide by -2. I better remember to flip those inequalities. 1 is now greater than x greater than or equal to -3. Whoops. So if I was to put this on a number line, -3 is the smaller one. 1 is greater. The -3, if you look at the inequality, that it's greater than or equal to, so it's going to get a full dot. The 1 is just greater than, so it's going to get an open dot. This is an and problem, and and problems we shade in the middle. We got one more that we're going to do together, and then you're going to try one, and it's an or problem. Ooh, I know or problems are shaded towards the outsides because they don't have any overlapping solutions. Solve 6x minus 5 is less than 7, or 8x plus 1 is greater than or equal to 25. We just solve them separately. Here we're going to add 5 to both sides. 6x is less than 12, and we'll go ahead and divide that. X is less than 2. Great, we'll come back to that. 8x plus 1 is greater than or equal to 25. We'll subtract 1. 8x is greater than or equal to 24. We do have to divide that by 8. X is greater than or equal to 3. Again, we saw the word or, but even if you didn't, there is no number that's less than 2 and also magically greater than or equal to 3. That's not possible. Always put your small number on the left. 2 is our smaller number on the number line. Less than 2 would be open dot, shaded left. Greater than or equal to 3 is a closed dot, shaded to the right. So I got one here for you. Pause it, try it, check back in. Pause it, try it, check back in. Woo! Plus 1, 4x greater than or equal to 8. Go ahead and divide by 4. X is greater than or equal to 2. Over here, plus 1. 5x is less than negative 5. Divide by 5. X is less than negative 1. Nice. So negative 1 is the smaller number. That would be on the left. Negative 1, it's less than. So it would be open dot, shaded left. 2 is greater than or equal to, so it would be filled in dot, shaded to the right. And that's it, folks. We did it. We did some compound inequalities.